Welcome to the Partners in Digital Health Institute Startup and Early Career Incubator, where we empower members to amplify digital health solutions to drive more constructive dialogue to accelerate a new global health era. I'm Tori Sinai, founder and publisher at Partners in Digital Health, and excited to moderate our webinar featuring guest speakers Raphael Brown, CEO and founder at Symbol Zero and Microsoft Regional Director, Silicon Valley, California, Mr. Charlie Northrup, CEO of Neurosciences, and Sweta Sneha, PhD, Executive Director and Healthcare Management Informatics, Professor of Information Systems, Coles College Business at Kennesaw University. Today our topic is, will the real metaverse please stand up? Thanks to the gaming industry and technologies such as AR and VR, where users are immersed in visual, auditory, and haptic sensors to virtually engage with others, the metaverse has been ignited by Web3 and blockchain tech, facilitating ownership, online payments, traceability, data security, and more. Users can create and participate in real-world experiences that are redefining how we communicate and what we share to impact conditions and experiences around and with the world. So, how does this fit into healthcare? Let's listen now and learn more. Hello, and thanks for joining us today for part one of our series discussion. I'm going to get right into it with our panelists, and the first question for them is, what's your impression of the current hype around Metaverse? Raphael, let's start with you.
Sure. So I think that the hype around Metaverse is a thing that is coming out and kind of fueled by the pandemic. It's accelerating work that is being done, but the painful reality, I think, for some is that some work can only be accelerated so much. So the hype around the metaverse is that a lot of people are going online much more than ever before. They're discovering new aspects of the internet that they hadn't realized. And in many cases, they're mistaking the being online that many of us have taken for granted for the last 5, 10, 20, 25 years for the metaverse that we're trying to get to in the future. So there's a thing that we're going towards, a 3D successor to the internet, and that's going to take, a good 2 to 3 decades to get there. But in the meantime, people are discovering the current reality of the internet, which is rich and robust and has a lot of things for us. More people are realizing what some of us have taken for granted, and it's frankly our responsibility to onboard them, to show them what's here, and then to kind of point down the road and show them where we're trying to get to.
Thanks. Charlie, your perspective?
It's really quite funny because the metaverse is being used for different naming and different people have different definitions of what they expect the metaverse to be. And in the gaming world, there's a very well-defined kind of view of what a gamer would view and consider the metaverse. But business came along and business said, hey, we can do this one better. We're going to make a metaverse and we're going to interconnect people. You'll have all this really cool audio video, and you'll be able to take part in things. And it just escalated so quickly that people lost focus. They started talking about all the possibilities without talking about how are we going to get there? What's the framework that's going to enable us to have this thing called a metaverse? And one of the things on LinkedIn was I found, Raphael was out there saying, hey, wait a minute, people, hello. There's a lot of work that has to be done. You can't just throw a switch and think that this is going to happen overnight. And so Raphael and I became friends based on this. Like, it was a great introduction to meet him and learn about all of his work. But yeah, there's a lot of hype, but I think there's a way to get there. And when we get there, it won't be controlled by the internet anymore. And that's going to be the most fascinating part, because the internet and the web become things inside the metaverse, not things that define it.
Okay, so that leads me to the next question, which is, what is your personal vision or version of the metaverse. So Charlie, let's begin with you.
So my vision is that there's a hyper-connected world. And when you start building the hyper-connected world, everything can suddenly become interconnected. Doesn't mean it has to, but it means it could. And as I went down this road of exploration, trying to understand how do you have this? How would it be possible to interconnect everything? And is it static? Is it centralized? Is it decentralized? And as we continued down this road, we realized that every person, place, and thing can indeed be represented in a hyper-connected world. Okay, that's great. But when you realize that protocols are things and tokens are things, and they become things inside the hyper-connected world, that's when you suddenly realize the web is a thing. It's a resource. It's a thing inside the hyper-connected world. It is not a thing that defines it. The importance of getting to that statement was to understand also that every blockchain is a thing. It's based on a protocol. Protocols are things. So they're inside the hyper-connected world. They're not things that define it. And then you realize when you get to that level, you suddenly say, well, what about machines that can communicate without using the internet? What if a machine can communicate using, like people, what if it could use voice and a microphone? What if it could use a speaker and a microphone? And very quickly you realize that that is indeed possible. It could also use optics, and it could see things. When you create those models and they have no networking connectivity at all, a machine that has zero networking connectivity, but it can still take part in the hyper-connected world, that's when you start to realize that this is beyond the web, this is beyond the IETF, the ITU, all of these standards organizations, they become standards within the hyper-connected world. That leads to the next logical question, which is who is defining the standards for how all of this comes together?
Okay, so let's turn this over to Raphael now. Raphael, your personal vision or version of the metaverse.
Sure. So, so my version comes out of science fiction. There are elements of science fiction that have galvanized and inspired many of us to go towards this. So the things that I would reference are actually going back to the movie Tron, 1982, William Gibson's Neuromancer, also in '82, and then the Sprawl trilogy, where he coined the term cyberspace, where in Tron it was the grid, a 3D, real-time 3D synchronous online experience. With kind of a hyper reality, as Charlie is talking about, and then that of course led in 1992 to Neil Stephenson writing Snow Crash, and then shortly after, I think a couple of years later, the Diamond Age, where again Snow Crash, he coined the term the metaverse, and he goes heavily into reworking and solidifying the notion that Gibson had 10 years earlier. And then in the Diamond Age, he dives heavily into AI and a notion of AIs both as sentient, but also as learning tools. And so this notion that AI is part of it is also very essential. And that AI are part of the networks, that the networks are not dumb. And so we take those ideas, and you can layer on Ready Player One and any number of other things. But to me, that kind of early notion in the 80s and 90s inspired a lot of folks in games. It inspired us because we said, we can build these worlds, but it also inspired a lot of the folks, frankly, in the early tech companies, both in terms of software and semiconductors. There were hardware folks, building displays, building component parts, thinking, I can build us towards this future. And so it's this realization of if you will, a metanet physical infrastructure that a metaverse can sit on, that collectively could contain but go past the internet and the web. And so the last thing, I'm a designer, to kind of leave you with a metaphor. It's not just a VR thing. I like to think of it, if you think of it in terms of like an atmosphere around the Earth, we build information around us. And at a certain point, we're going to build spheres of information circling this globe. And some of those need to be more VR because they're fully virtual, and some of those need to be more AR because they contain information to connect into the physical world around us. And some of those need to be a bit more MR and mixed. So it's this notion of probably clouds connected by blockchains. And we're still trying to find the mediation of public and private, but a notion of information, spheres of information circling the globes, effectively like our atmosphere, but of bits and bytes, and with the notion that there's this hyperconnectivity that we can get to if we keep working at it. So the last thing I'll just say related to that is that I view it kind of like going to Mars. It's probably going to happen. We can get there, but it's not around the corner. There's a lot of really hard work to get there, but it's kind of essential work. And like going to Mars, we have kind of a moving target. And it really comes down to when we sit down, stop fooling ourselves that we're there already, and do the work in step, pace by pace, until we actually get there and land.
Thanks for that, Raphael. Charlie, this one's for you. And not to make it more complicated, but what is Turing's child machine, and how might it impact value ecosystems in the present and future?
So in 1950, Alan Turing, in one of his early papers, he had suggested that we ought to build a machine like a little kid, and that through education and experience, the machine should be able to evolve. So it's a fascinating question about this, whether or not anybody has ever built such a machine. But we started on the journey of how could you possibly build an Alan Turing child machine, and could you do it today? What would be the implication, and what do you need to do it? And it turns out that in our version of it, the answer is yes, you can build it. And we built our first version in 2016. And what it means is, to give a simple example of this, it's the idea that you could build two machines. So if I have two machines and they're absolutely identical, and I put them in two different locations, through education and experience, can those machines evolve differently? And so when we built it, we realized that the processor that we created could actually go in a vending machine, as a simple example, because everybody knows what a vending machine is. All right, so vending machine, Alan Turing child machine, put it in two different locations. Person goes up, presses F4, gets a bag of chips, and the machine has a speaker, and it says, "What else can I do for you today?" And the person could say whatever they want, but the machine wouldn't understand what it is that they're asking. And so both machines could be doing this at the same time, two different locations. Although they can't understand what the person is asking, the machine can classify. So it can classify what is the topic of conversation at this particular location. What am I being asked about? And if the machine can classify, it can keep track of the number of the types of conversations. And it can eventually decide through logic that, oh, everybody here in this location, they are talking about how do I rent a car? How do I change a flight? How do I get a taxi or an Uber? How do I get a hotel reservation? Because that particular machine is sitting in an airport. The second machine is sitting in a middle school. And so every time that a kid goes up to it and
I think we've lost Charlie's video. Sorry.
Oops, sorry about that. Every time that the kid goes up to it and puts a dollar in and gets a bag of chips, the machine would be asking the kid, what else can I do for you? And now the machine is going to learn about what are the topics of conversation in a middle school. That topic of conversation is going to be very different from the conversations in an airport. But both machines, now that they know what's important to their particular environment, the machines can reach across the network and go to the bookstore and say, I need books about this particular topic because that's what's important here. And so the machine can then read these books to learn how do I rent a car? How do I get a hotel reservation? How do I change a flight? And essentially the machine evolves from being a vending machine to being a travel assistant. And so this is what we built. We figured out, how do you do this? How do you build these kinds of machines? And then what are the endpoints? Where does this go? And eventually we could postulate that the machine would have an existential crisis at some point, that it wouldn't know what it's supposed to do. How do I provide useful work? What if we gave the machine a goal and said, here's your goal. Your goal is to provide useful work, and this is the type of useful work that you can do. Well, if that particular useful work is no longer important in that environment, it's kind of like the machine having an existential crisis and saying, well, what am I supposed to do? How do I evolve? How do I, as a machine, in order to do this, how can I best serve humanity by evolving? And that's what we mean by an Alan Turing child machine.
Okay, so now we've got vending machines and we've got tourism, but the question is, are there applications for healthcare specifically, and in what areas? So Raphael,
Yes.
do you want to start? Let's get you back in here.
Sure. Yeah, so I think that there are a lot of applications for AI in healthcare, and think of it this way: there are so what we have right now is a lot of exploration where people are doing things in the local, on their own hardware, pushing it out to some amount of cloud. But we have more access to computing in about the last 5 to 15 years than we thought that we had before, because we can extend computing beyond our devices, and so that's both useful for exploring and creating, as Charlie's talking about, but also for setting up services, and whether it's to healthcare or to other enterprise, you don't just have to go, what can I run on device, but also what can I push to elsewhere. Really, the funny thing is, in many ways, the first application that a lot of people saw this was with mobile phones and things like voice assistants. All of a sudden, we have new functionality where the most immediate thing is, can we use it to order something? There's a whole array of these tech companies where they found a basic consumer application in order to justify voice AI. But the reality is, whether that's some amount of voice recognition or machine translation, or if it's diving into bits of machine learning, reinforced learning, deep learning, neural networks, or other things, there's a lot of ability now to go between, I am here on a device, which could be a PC or a mobile phone that needs to access a service, or it could be I've put a headset on and I'm wearing an AR MR headset, but you don't have to go, what can I just run on the device, but also what can the device connect to? What services and networks can the device connect to? And can I feed it some amount of information through text, through voice, through a link, through any other things? And then it pushes out and says, okay, I'm putting this into a network, and I've got 10,000 other diagnostics in here. The potential for comparison and analysis, whether it's in healthcare or construction or education or a number of other areas, we can expand beyond the device, and we can push and run things elsewhere that can be running in the background and then give me a result when they've been able to. So there's both the ability for real-time comparison and then sending a thing off to a network or a cloud and going, churn on this for a while and feed into this larger network, and then give me something back when you're ready. But that potential to go beyond the existing device is intriguing, because it has the ability to go back and forth over time as we find ways to integrate them between cloud and edge and blockchain and other things that we might not yet have figured out. But it's the notion of it, like, these are all computing devices in arrays, and it's just how do we organize the information. So it's exciting for that. But I know I'm still speaking in vagaries, but there's a great amount of processing that we can do once we start connecting computers together. And just a simple thing that I would say is expanding the ability of a healthcare professional to get information quickly and to compare that information, because the biggest thing that we have to remember is that a lot of what we call AI, quote unquote, and I'm sure Charlie will go into this much deeper, is not really AI. A lot of it is really accelerated human learning. It's human comparison directed by human algorithms. And a lot of what we have that we call AI in these spaces is really just, can human thought be pushed over into a network and then churn for a while and give us something faster than humans can do it, but using the same basic processes that humans have.
All right, Charlie, you're up, and I know you're chomping at the bit for this one. All yours.
Well, I think that the COVID pandemic has definitely challenged AI, right? And so we've spent a lot of time and money building out data sets and training sets and trying to get AI to be able to predict things more accurately. And a large portion of that hasn't really succeeded as well as everyone had hoped. And it raises some fundamental questions about the way that we're approaching AI. Is it the right way? But to Raphael's point, once we start hyper connecting everything together, the big issue is going to be, how do we share that data? How do we share the information from one platform to another platform, or one machine to another machine? And what are the rules about doing that within HIPAA compliance or other sets of compliance for privacy? So on one hand, we have a whole privacy issue that we have to deal with. On another hand, we have all of these machines that are being built right now, and they're running in silos. So I think of healthcare, a lot of healthcare, and the machines and the tools that are available, they're being managed very much like the way we manage the web. Everything is in a separate silo. The thing that's missing, in my opinion, that one of the fundamental things that is missing is that the user, the patient, they're not actually represented in the digital world. They have no point of presence, no ability to automate anything. They have no way of being able to say, hi, I exist in this digital world. The only place that they do exist as a client of somebody else. They're stuck inside a website, they're stuck inside a domain, they're stuck inside a particular vendor's healthcare solution, and they can't move anywhere beyond that. They're literally, you exist only inside there. So there's no way to have real patient advocacy and patient rights in that model. So there's a lot of work that still needs to be done. But I think that once we get to the point where the patient can be represented and the things that are important to the patient can be taken into consideration, that being able to say, I have this agent, and the agent's going to evolve around my needs, not yours, but around my needs. And it's going to become more customized. And that's how we'll be able to start interconnecting all these pieces that need to be interconnected.
So it sounds to me like we've got quite a bit of work ahead of us, considering that Raphael started 30 years ago. And so next question that perhaps gets back to the patient as well. Should we expect a holographic interface society, and when? And will this be a cross-platform world? And when do you anticipate graduating from the anime we see at present for a mature, operable model for societies and cultures? So, Raphael, I'm going to go to you.
Sure. So we have parts of that now. Microsoft in the last couple of years has been rolling out bits of both the Azure Connect and then the Azure Precept, which is a camera, a hardware and cloud connected camera that can scan and do photogrammetry, and then the cloud services behind that. So there's parts of that now. We can do bits of that, and in a variety of different bits of hardware and services. But we've kind of came out of 360 video to the point of where we can better scan and put into photogrammetry, and even potentially in rough form process in real time a photoreal representation of a person, and so there is the ability to do that and bring that across and put that into a call. Right now, it's not the most accessible thing, but it's getting more so. And I think that the thing to balance that with is that again, people. I can remember watching the movie the Kingsman, and again, people kind of see things in fiction, and we're constantly back and forth between life imitating art, imitating life, imitating art, and so in the Kingsman, you have a bunch of people sitting down at a table, but they're all sitting at individual tables, and effectively they're all kind of brought together so that they appear to be at one table, because there's a combination of augmented reality and holographic projection. We're pretty close to that. So, a holographic society or using it widespread is still going to take a while, and will probably roll out over bits of the next 10 years, and will gradually get put into larger networks. But we have the start of it right now.
Thanks. And that kind of reminds me of Dune, actually, probably the more recent one as well. Charlie, do you want to take that question now?
Sure, I agree with Raphael. There's a lot of really cool work that's been done, but I do think that there's still a lot more to go. When you think about how we as a society have adapted in the COVID pandemic to telehealth, and that telehealth is now a huge thing. But prior to the pandemic, it was always like, oh no, I'm going to go see the doctor. I have a doctor's. I have to drive to the doctor. It was all about that human face-to-face interaction, and now all of a sudden, people are dealing with it over the internet. And so it's fascinating to see how the pandemic has both hurt us and helped us advance in many, many ways. And eventually, I think that the whole holographic imagery is it's gonna take a giant step forward, it's that three-dimensional view that sometimes people really makes them feel better about who I'm talking to. It's like they're really there and they have that presence. In terms of other work, though, you have to look at what else can we do with holograms. Is it more than just people? And so one of the things that our company focused on was, how do you create holographic memory ID tags? We call them HMID tags, like an RFID, but HMID. And this allows us to say, okay, well, we can create a holographic image of an identifier, and we can attach it to a real world thing. And now with a smartphone, 3.14 billion people can just use their smartphones and scan these holograms. And then now what that does is it says there's a thing in the real world, the physical world, and you can identify it by scanning the hologram and pulling up the digital twin of that item. So,
all right, let's talk about, did you want to add something, Charlie? Sorry.
Yeah, I'm sorry, there was a truck going by. So I think that this idea of being able to move identifiers from the real world into the physical, the digital world, and then be able to say, hey, in the digital world, there's an identifier. Where's the physical item that goes with it? And now all of a sudden we can do that. That becomes really powerful. That's a very unique way to do things. We could do things, for example, in the supply chain. Why this matters? Think about the pandemic. During the pandemic, there was real serious concern about healthcare products coming through the supply chain that were counterfeit, right? But if you had a holographic ID at the time of manufacturing, then what you'd be able to do is you'd be able to say, I'm manufacturing this item and I'm applying this holographic ID to the item. I'm going to scan it and I'll enter it into the data set onto the blockchain or the ledger, saying that I'm the manufacturer of this item. And now it can go out into the supply chain. As it travels through the supply chain, anybody who touches it could actually scan it with their cell phone. And you would be able to then, as the end user of that product, you'd be able to scan it and look at the entire provenance of documentation and control to prove that this is indeed a legitimate item. And so for healthcare, it's huge, but it also applies to everything else in the supply chain. It's not limited to just healthcare.
So, Charlie, I know your company now. Raphael, you mentioned Microsoft Azure, but what companies out there are leading the development and perhaps even best practices for holographic interfaces at present? Raphael?
Sure. So, so in terms of holographic interfaces, Microsoft is definitely one. I think the way to think of it is that there are a few different parts of this. Microsoft has definitely been actively involved in kind of the scanning and pushing more of that to the cloud to enable it to be a bit faster, and has been building up an array of services. So Intel has been doing a lot with holography. Some of the most interesting kind of location-based examples of holography being used for teaching and learning that I've seen have come out of Intel. So Microsoft, Intel, Sony, Google's done some work as well. It's kind of funny that often one area people are talking about how like big tech is bad. A lot, they may move a little slower. Sometimes it may take them a while to kind of realign their aircraft carriers and turn in new directions. But you often have a lot of good people and good researchers in there that are trying to take advantage of the resources that they have to do really interesting work. And so, yeah, I've seen interesting bits of holography come out of, Samsung is another, going back to Sony. Sony's interesting, not there because of PlayStation, but because they make, some of the sensors that people use. There's kind of this focus of being able to scan the thing, then being able to process it, then being able to push it out to others. So that there's a bit of cloud, there may be some network. Another distinction to make is that oftentimes we don't want to put these things on the blockchain, but rather, the distinction like that like the Hyperledger folks would make is to put it onto a distributed ledger that may be private and enterprise focused, because you don't necessarily want to have, like in healthcare, information from individuals or clients or medical communities in public spaces. Privacy is still very important, and we can get into that into things like biometrics. But the core is that blockchain, people often kind of throw out as a general term, but the important thing to remember is that, like, no, we really don't want to put everything, for example, onto Ethereum, because it's really slow, it needs small amounts of data, and it's not necessarily going to give you privacy. But that doesn't mean that there aren't things similar that can do different parts of that are more specialized. So that there's a lot of tools, and if anything, blockchain as a generalized concept is just starting to find its use cases. And so we need to then go, right, what we actually want to do is this, this, and this. Okay, do we have a tool that does that? Yes, kind of, but we need a better one. And then they evolve. So we're getting to a lot of that right now, because we're kind of coming out of going, I'm sitting down looking at these tools and I almost have what I want, but not quite. So dissatisfaction is the mother of invention.
Yeah.
Charlie?
I agree. I think that in terms of privacy and the question of blockchain, we're still operating in a very siloed world. So imagine that I put all of my healthcare data on one particular blockchain, and I have tokens, and there's an economic model associated with that one particular blockchain. Well, what happens when a better blockchain comes out? How do I move the data off of one blockchain and put it on another? And that's actually a really tough thing to do. And the idea, it's like trying to move your cloud data from one cloud provider to another cloud provider. It's very expensive and very difficult to accomplish. And so I think there has to be a different model. To Raphael's point, that we're looking for this different model where I can be represented in the digital world and I own all of my own data. And so I carry that data with me, and I give you the right to access it or not access it, but it's my data. And people have talked about this as self-sovereign identity, but it's different than self-sovereign identity. It's really about saying that I should be in charge, I should be represented in the digital world, and I should be able to put things where I need them to be put, and I need to be able to share them. So you need this trusted exchange of information and value between the different providers, even the different providers in healthcare. Classic example, if my GP tells me to get some tests done and I have the test done, now I have to get it to my other specialist so that they can look at it, or vice versa. So a specialist tells me to get a test done, great. How did I then share that information easily with not just the specialist, but also with my GP? It's a very, very complicated problem. And because of HIPAA and other GDPR requirements, it makes it extremely difficult for you to authorize it. So if the specialist has my healthcare data and I'm saying share it with my GP, they may not be able to do that immediately. And you're going, but wait a minute, it's my data. Andy Martin on LinkedIn, he spent a lot of time looking at this problem, and really big advocate for this idea, especially in healthcare, that you need to be able to own your own data, and you should be able to say what and with whom that data is going to be shared, and it should just happen.
So let me ask you this, going off now, what role, excuse me, does 6G play in all this? We've heard enough about 5G, but 6G has now reared its head. So what are we looking at? Where are we taking that, Raphael?
So I think the thing that we have to keep in mind is that we always have a balance of different bits of broadcast. So we're now on roughly 10-year cycles for cellular, but we have to keep in mind that marketing dollars are put into migrating people from one cellular generation to the next, and that they kind of understand these 10-year cycles that we've elongated out to. 5G, 4G was useful. 5G is a little bit more useful. Like they always oversell and underdeliver. And to take 5G for example, the best 5G rollout so far has been in China. The US has a very underwhelming 5G that's slowly getting better, but likely there is no G that is a game changer. The reality is that it will slowly become more useful to have cellular connected specifically to XR devices but most XR devices right now are primarily used at home or at work because they're not really built for travel, and their sensors don't really deal with daylight or with vastly changing light, and really don't deal with night at all. And so we're not ready from a sensor perspective to have a set of XR glasses that you walk around with all the time, because the sensors can't handle it. They can handle a good office or living room environment, and because of that, what they're primarily doing is they're connecting wirelessly on a network. So the vast majority of our computing is still wired with Cat 5e, Cat 6e Ethernet, and then with some amount over wireless. Network and Wi-Fi and cellular all kind of go hand in hand, and what we actually need to do is not get caught up on cellular, which will eventually, probably more with 6G than 5G or 7G, somewhere around in there, will go, hey, we've got the sensors all sorted out and you can walk around, and Apple and Samsung and Google have perfect glasses, and that's 2030 and beyond. But right now, what we have is mostly just lots of little experiments, and Wi-Fi 6 is much more of an impact than 5G. So we'll see if that reverses, but it may or may not for 6G and Wi-Fi 7.
Okay, thanks, Raphael. Charlie, getting back to your sweet spot now, what's the difference between human cognition and robotic cognition?
So it's a really fascinating journey that we have been on, trying to understand this whole process. But effectively what we did was we created this idea that there's a universal framework of things, and the things in that framework are really, really simple to understand. It's something a machine can do, something a machine can act upon, something a machine can use, period. So there's only 3 types of things in our entire universal framework of things, but it becomes, even though it's so simple, it becomes hugely complex really, really quickly. And it's fascinating to see it all. For example, if a thing in the framework is something that a machine can do, well, we could classify that as a verb. And if a thing is something a machine can act upon, that can be a noun. Something a machine can use, a modifier. All right, so we have nouns, verbs, and modifiers inside the universal framework of things. And this is what gets represented inside the machine's digital brain, nouns, verbs, and modifiers. And so it became interesting to say, suppose that you could define a runtime where the runtime only uses the nouns, verbs, and modifiers inside the machine's digital brain. So this way, then the machine would be able to understand what you mean. And if in defining the runtime. And the last piece was, well, what if you took the machine and said, you have a verb called perform. What if you could perform the runtime? So now you're using the graph inside the digital brain. There's a graph of things, which are all the vocabulary, nouns, verbs, modifiers. So you're using this graph to say, inside the graph, there's a word called perform the other thing in the graph called the runtime. And it starts to put the graph in motion. And as the graph goes in motion, it becomes very, very simple to say, this is a machine, this is its runtime. But what happens if when you start to look at it, you say, well, what can we create models of? What kind of things can we put inside this graph? And what kind of verbs do we want? And we found the most fascinating one to us was the word contemplate, because contemplate allowed the machine to have more of a cognitive model. It's not the same as human cognition. Everything we do is we create models. We observe things in real life and we create models about how they work. And as long as we can convey the model using only the vocabulary the machine understands, just like a little kid, when you're asking your kid to do something, you have to use words they understand. So if we can convey it to the machine, then the machine can learn what that is. So when you look at the basic cognitive process for a machine, the model that we chose was to say, basically, you have to be able to create a thought that may be from using your listening vocabulary, it may be from using your reading vocabulary, or it may be that you just contemplated something inside your digital brain and you created a thought. Once you create the thought from the machine's viewpoint, it has to run a contemplate model to contemplate, what does that thought mean? Is it something I can do? Is it something I shouldn't do? Is it something I can ask somebody else to do? Or like a kid, can I pretend like I didn't hear it and just walk away? And so you go through this level of contemplation about what something means in order to figure out what you're going to do. And then the machine has to perform whatever it's going to do. And once you put this basic model in place, you now have a relatively simple but interesting model of robotic, a model of robotic cognition. Again, not human, it's a model, it's robotic, it's machine-based. But when you start adding on to that, and you add the word learn, what does learn mean? Well, learn just means to add words to the vocabulary. And that's when you start to realize that a machine could actually have a cognitive model where it can read something and it can say, what does this mean? Oh, it means that I'm supposed to learn a new verb. And the verb that I'm learning is how I can gain additional input. Or the verb that I'm learning is how to contemplate even smarter, better than I do at a second grade level. Could I contemplate at a 5th grade level, 10th grade level? What about a PhD level? What would all of these mean? And so all of these different models start to come together, and this creates robotic cognition.
Raphael, do you want to add anything to that?
No, I actually am just going to say that Charlie's going deep on that, and I love listening to it. So we've actually got a lot to cover. So I'm perfectly happy with that. Friendly amendment, yes.
Okay, thank you. So Charlie, another deep one for you in that case. What's the difference between human consciousness and robotic consciousness?
Wow. So this sent me on the journey of a lifetime trying to understand. There were so many rabbit holes to go down and try to figure things out. So the first thing we can say is, what is human consciousness? And the answer is everybody has a different definition. So even the philosophers don't agree on exactly what human consciousness is. So that's easy because we can say, don't know really, but we kind of recognize it when we see it. The way that I think about it personally is human consciousness is all the things that you're aware of at a moment in time. And actually, I got that from my daughter, Brittany. She was the one who helped me to kind of straighten out and come up with a base definition. So human consciousness is all the things that you're aware of at a moment in time. John McCarthy, the father of AI, wrote a paper about could you have ascribing mental capacities to machines. And that set off a huge debate in the philosophical world about whether or not machines could ever have a conscience and could they have consciousness. And the next part that became interesting was Professor John Searle from Berkeley, a philosopher. What he described it as in one of his emails is human consciousness is something that is intrinsic to nature. Right? It evolves in nature. So it evolves inside the 100 billion neurons that make up your brain. And the best that we could possibly do is we could observe it. And if we observe it, we can create a model about how we think it works. And with the model, we can create a computer implementation. So at best, what you have is a computer implementation of a model that somebody created after observing something that is intrinsic to nature. You never have the original thing. So there's a big difference between them. So in robotic consciousness, it is more about the states of being inside the machine of all the things that the machine is aware of at a moment in time. Versus in human consciousness, it's all about the things that a human is aware of at a moment in time. But it's, again, that's based on something that's intrinsic to nature.
All right, we're all following this, Charlie.
Could I actually jump in on that?
Oh yeah, absolutely.
Yes. So So bringing this back to games for a minute, because in games, we're often very focused on trying to run a lot of things in real time on very little hardware. um, as a perspective, in games, we've never really tried to go like, can we create consciousness? We're mostly going, can we, and it's a little bit to, very crude versions of the Turing test. Can we create the illusion, the very temporary illusion that you have other people, other personalities, we often call them NPCs, but as non-player characters, but that you have others around you, and that whether it's a crowd or an individual, can we provide a temporary illusion that you very quickly know isn't a human? You can tell, like, oh, these are the humans and these are not, in a group setting. But can we provide a temporary illusion that has some reactivity, that follows a particular set of rules, that at least allows you to go within the context of this story or world or simulation? I can have a representation of people or creatures or things that need to be functional and interactive. And so, like, we've been doing this in VR, we've been doing this in games, but not really consciousness or sentience, but just, can we have reactivity? And according to some rule sets, and we've often had really crude state machines to do that. Oftentimes what we're doing is going, hey, so in our overall processing and scene rendering, we can put about 10% towards AI, because you've got graphics and physics and audio and AI and user interface and a whole bunch of other things, and you're compartmentalizing and cutting up this scene rendering pie, and AI gets this little piece. The thing that's been interesting in this last while for games and VR and simulations, and gets into healthcare as well, is going, if we can supplement the rendering on device to some amount of cloud or edge, or even to a local array that you might have, we're not just rendering on device. And I'm going to kind of hammer on this, because we're still, like, rendering consciousness is a thing that we don't know how to do yet, but we are starting to get to rendering a certain amount of consistency and persistency in the interactions, such that at least that illusion grows a little bit more, that we can effectively go, I know that this isn't a person, but this is an AI stand-in for a human that might be running me through a diagnostic or a tutorial. It might be explaining things to me. It might be asking me questions. There might be a certain amount of effectively call and response or Q&A. And in that, I need something that's more, like, people will need things that are more than just a menu. And so, bring this back to healthcare, a representation of a person that is responding to you, and they can't have all the functionality of a real human, but in specialized areas they can respond and react and ask questions. Breaking it down into these bite-sized chunks and going, what can we run with a combination of real time on the device and pushing out to some amount of network services around? It's still night and day from what we could do in the 90s, where we're mostly like, these things can move around as points. And, like, we started with arcade games and going, just, can we have them move? And then we're like, okay, can we have them be aware of you and run away from you when you try to shoot them? Now we can have them go through and look at questions, and even go, compare this to other questions that have, go into this database, look at these questions, see how people have asked and answered questions before, and then coming back to this particular doctor and patient, when the doctor is asking the question and the AI, which doesn't always have to be represented, it could just be, think of it as, metaphorically, the AI could be sitting on the shoulder of the doctor as the questions are being asked. But whether the AI is asking the questions and is the doctor, or is helping the doctor with the analysis, we have more resources than we could before. So it's really this idea that like there's a whole field of AGI that we are starting to explore, but there's a lot of really basic things that we can start to do where we can go, okay, if I can just extend my own intelligence a little bit and put it into this little pocket of a thing, this thing can go and ask a bunch of people questions in a environment that might effectively just be, hey, it's on their iPad. We can get to holography, but if we can do telehealth and telepresence a little bit better, and have it be better than than an AT&T voice menu, then we will make great progress.
All right, so we're going to wrap it up here for part 1 of our webinar. Will the real metaverse please stand up? And part 2, believe it or not, we'll be going even deeper with implantable sensors and common ontologies and on and on and on. So I want to thank you, gentlemen, both for taking the time and sharing your thoughts and expertise with us.
Absolutely.
And we look forward to part 2 very, very soon with you both. Thank you
very much.
That sounds great. Thanks, everyone.
Take care.
We appreciate your tuning in to the Partners in Digital Health Institute. Thanks for listening today. And to keep up with webinars, podcasts, and other tools for your career and business, join the Partners in Digital Health Institute at pdhinstitute.com and click Join. To learn more about our bootcamp partner, ISMPP, please visit ismpp.org. Join and engage with programs available. Stay tuned for upcoming sessions to guide and provide insights to help navigate your professional career knowledge and strategies. Coming soon.